lecture series of the Mathematics 1. Today our topic is Taylor series part 2. In Taylor series part 1, we are discuss about the form number 1 of the Taylor series as a power of x minus h. Second form as a Taylor series in the power of h. Taylor series in power of h but replacing by the a by x. And form number 4, the Taylor series in power of x, interchanging x and h, and we get f of h plus x equal to f of h plus f plus h plus x plus f plus h upon 2 factorial x square up to. In last session, we are discuss about the form number 1, form number 2 examples. So today we are discuss here to example of the form number 3 and 4. Okay, we are start from the example. First example is so that log x plus h equal to log h plus x by h minus x square upon 2h square plus x cube upon 3h cube up to. Now we taking f of x plus h equal to log x plus h, f of h equal to log h. By the Taylor series, f of x plus h, f of h plus x upon 1 factorial f dash h plus x square by 2 factorial f double dash h, f of h equal to log h, f dash h equal to 1 by h, double dash h equal to minus 1 by h square, and triple dash h we getting 2 by h cube. Put all the value in the equation 1, so we get f of x plus h equal to log h plus x upon 1 factorial plus x square by 2 factorial minus 1 upon h square and x cube upon 3 factorial up to. This is the Taylor series of the log x plus h equal to log h plus x by h minus x square upon 2h square plus x cube upon 3h. Now next example, expand sin pi by 4 plus x in a power of x and evaluate sin 44 degree and sin 46 degree. First of all, f of pi by 4 plus x equal to, we are comparing with the sin pi by 4 plus x. So, f of h plus x equal to sin h plus x, we get h equal to pi by 4. What is our f of h? It is sin h. By the Taylor series in the x formation, we get f of h plus x equal to f of h plus x upon 1 factorial f plus h plus x square by 2 factorial f double dash h up to. We are using here Taylor series form number 4 due to, as an example, say that we can expand sin pi by 4 plus x in the power of x. So, put h equal to pi by 4, we getting f of pi by 4 plus x, f of pi by 4 plus x upon 1 factorial f plus pi by 4 up to. F of h equal to sin h, but f of pi by 4 equal to 1 upon under root 2. Now differentiate f of h, we get cos h, replacing h equal to pi by 4, we get 1 upon under root 2. F double dash h equal to minus sin h, f double dash equal to pi by 4. We are putting minus 1 upon under root 2, we get f triple dash h, that is minus cos h, so we get minus 1 upon under root 2. From equation 1, we have put all the values of the f pi by 4, so we get the series in the form of the f sin pi by 4 plus x equal to 1 upon under root 2 into 1 plus x minus x square by 2 minus x cube by 3. This is our equation number 2. Now, we have to find sin 44 degree. What is sin 44 degree? This sin 45 degree minus 1 degree. Now compare with the sin pi by 4 plus x. So, x equal to minus 1 degree equal to minus 1 into pi by 180. Equal to minus 0.01745. We are converting 1 degree into radian form and put into equation number 2. So we replace x equal to minus 0.017 and hence evaluate we getting approximate answer of the sine 44 degree 0.6947. Now find sine 46 degree. Sine 46 degree equal to sine 45 degree plus 1 degree. Compare with the sine pi by 4 plus x equal to 1 degree equal to 1 plus pi by 180 equal to 0.0174533. Put into equation number 2, we get sine 46 degree equal to 0.7193. So, this way we getting the value of sine 44 degree and sine 46 degree. Next example. Using Taylor series, evaluate under root 36.12 up to 4 decimal. Here, under root 36.12 we can write as a under root 36 plus 0.12. X equal to 36, h equal to 0.12. F of x plus h equal to under root x plus h. F of x equal to under root x. By the Taylor series, f of x plus h equal to f of x equal to h upon 1 factorial f dash x plus h square by 2 factorial f double dash x. So, we take f of 36 plus 0.12. Here x equal to 36 and h equal to 0.12. And put all the value in equation 1, then we getting f of 36.0.12 upon 1 factorial f dash 36 up to. Now we have to find value of f of 36. So for that we taking f of x equal to under root x, f of 36 equal to under root 36. So we get value x is a 6. F dash x equal to 1 upon 2 under root 6. Replacing x equal to 36, we get 1 by 12. F double dash x, the differentiation of 1 upon 2 under root x is minus 1 upon 4x raised to 3 by 2. So F double dash 36 equal to minus 1 upon 864. Put all the values in equation 1, we getting under root 36.12 equal to 6.009 approximate answer. Hence, we evaluate by the Taylor series. Now, next example, we have to approximate value of sine 30 degree and 30. Here, 30 degree 30 equal to sine 30 degree plus 30. Sine pi by 6 plus 30 by 60 into pi by 180. We are converting 30 in radian form, so it is 0.087. Now, x equal to pi by 6 and h equal to 0.087. F of x plus h equal to sin x plus h. So, f of x equal to sin x. By the Taylor series, we are applying this series f of x plus h. Pi by 6 plus 0.087, f of pi by 6, 0.087, f dash pi by 6. How to find f of pi by 6? Again we take f of x equal to sin f of x equal to sin x. So, f of pi by 6 equal to 1 by 2. F dash x equal to cos x, then f dash pi by 6 is under root 3 by 2. F double dash x equal to minus sin x. So we get f double dash pi by 6 is equal to minus 1 by 2. From the equation 1, we get in sin 30 error equal to 1 by 2 plus 0.087 under root 3 by 2 up to. So last answer is of this function is 0.50752. In this way, we are getting all the values using Taylor series. Thank you.